Hello everyone, those who are live and online for the session, please say hi in the chat window so that we can start the session. जो स्टूडेंट्स इस समय पर ऑनलाइन है चैट विंडो के अंदर प्लीज से हाय. Hi Mary and Pratibha. Okay, so something wrong with it. Let me just change it. Just give me a second please. So I think I have to restart the entire system. जो नीचे line आ रहा है that is not correct. Chalo, anyways, let's do the class. So some of the section of the video might not be visible down under, maybe because of a strip. So that strip can only be corrected only after I restart the live stream. So I don't want to restart it right now. So maybe let's keep it here and then we will. Okay, let me try and restart the live. It will be available on the same link. Just give me a second. Hi, those who are present for the session, please say hi in the chat window so that we can start the session again. Hi Deepak, Pratibha, Mary. So जो students इस समय पर online हैं, please say hi again so that we can start here. So we'll अभी the time is 2:44. So 2:44 हुए हैं and we will start by 2:45. So in next 1 minute we will be starting. We will start. Hi Deepika. Okay. So in this session, as I said again, we will be discussing about the pushdown automata. And in this session specifically, we will be discussing about the non-deterministic pushdown automata or NPDA. This is non-deterministic. Right? I hope that it is visible to all of you. जो मैं लिख रहा हूँ सभी को साथ visible है. Is there anyone who is having any issues? If you are facing any issues, you can tell me. Otherwise, we can start here. Okay. So in this session again, we will be discussing about the non-deterministic pushdown automata. As I said, NPDA is more powerful as compared to the PDA. तो पुशडाउन ऑटोमेटा से ज़्यादा पावरफुल होते हैं आपके पास NPDAs. तो हम लोग यहाँ पर NPDAs डिस्कस करेंगे. प्रतिभा you'll get your answer. Don't worry. Just follow through it. You'll get your answer. So because there are few more concepts I have to teach you, then you will, if you go back to the previous case, you will understand those questions also. So basically, if you have a language like language is W such that W belongs to A comma B plus, right? Or let us suppose the language is A raised to power N, B raised to power M, C raised to power L, D raised to power K such that N is equal to L or M is equal to K. Now for these languages you cannot create a deterministic PDA. तो इन languages के लिए आप deterministic pushdown automata नहीं बना सकते. There are a lot of examples. I can take hundreds of examples where you will not be able to make deterministic PDA. So for these examples you can create non-deterministic pushdown automata. Okay, so let us take the first example here. So first example says w says that w belongs to a comma b plus, so that means w is representing a string. So that means if we have w which is equal to a b double a, then again if I take the string ww, that means it is a b double a and a b double a. Now for this string you cannot even create a NPDA. String के लिए आप NPDA भी नहीं बना सकते. You cannot even create a NPDA for this string. But if you have a string WWR, तो WWR के लिए आप NPDA बना सकते हैं. Why? So because if you write WWR, so WWR will become A B double A, again A double A B A. So you have the string. So what you can do is, in this case you can insert the string W onto the stack, which is A B double A, and when this WR starts from here, you can start removing these symbols from the stack, or according to this you can easily do it. Okay. Now the biggest problem is when we take the string which is WCWR, says that W belongs to a comma b plus. Now in this given string, because of this C, we know that the reverse of the string is starting. So C is basically acting as a markup, that if C is there, so after C your reverse of the string will start. So that is this WCWR. But here we do not really have a markup, we do not really know from this entire string what is the point where the reverse will start, because in case of pushdown automata we still do not have any method of counting. We can only store some data, but we cannot count. Let me give you a simple example here. So let us assume that this is something called as a barn or something, right? And here you have a lot of goats. Okay, these are the goats. Okay, and here this is a person, and let us name this person as Pratibha. Let us name this person as Pratibha. Okay, and there's one more person here which is Kavita. So she is Kavita. So what does Pratibha do? Every morning she takes out all these goats from the barn and she make them roam around the mountain or something, I mean the fields, and they eat grass and they always come back. Okay, they always come back in the evening. But the problem is Pratibha doesn't know how to count. Pratibha do not know counting, and this number of goats are huge, right? So she is having like hundreds of goats and she doesn't know how to count. Then how will she count? So we have to identify a way, then how can she count? And this girl Kavita, what does she do is, every morning when Pratibha takes out these goats, and every day she is just waiting for a moment where she can take one goat out of this and she can cook the goat and she can eat it, right? So basically we have a predator and we have a savior, right? So she is like a savior. She takes the goat out and she make them have some grass, she make them have some food, but she is the one who eats these goats. Okay. Now this is a big problem, right? For Pratibha it is a big problem because Pratibha cannot count. She doesn't know that if I took 100 goats in the morning, then I've got 100 goats in the evening. She doesn't know how to count. So what does she do? In that case, she takes a bag here, okay, and whenever a goat go out, she put a stone in the bag. Again, whenever a second goat will go out, she put another stone in the bag. Whenever the third goat will go out, she put another stone in the bag. So when all the goats are out, she's having some of the stones in the bag. So these are just small stones. So basically all these stones are acting as a unary number system. Unary number system, right? So now unary means we have only one symbol. So every stone is acting as a symbol. So we can count the number of goats with the help of this unary number system. So number of stones means number of goats. We can also have a binary number system. So in day-to-day life we use decimal number systems, but again in this case Pratibha is using a unary number system by collecting the stones. So in evening when these goats come back, so what does Pratibha do? She takes, whenever one goat go in, she takes one stone out. Whenever the second goat go in, she takes another stone out. Now after all the goats, when all the goats are inside, if there are still some stones left, that means some of the goats are missing. And how many goats are missing? That will be equal to the number of stones that are left in the bag. Okay. So this is a way how she can count, and this is called as unary number system, unary way of counting. So this is the same thing that you do in abacus, which child play. So, but when you use a pushdown automata, so pushdown automata does not know how to count. So pushdown automata use exactly the same concept here to count the number of strings. What does it do? A number of alphabets in the string. What does it do? It tries to store those alphabets in this stack. And whenever there's something else is coming, it takes out something. So in this way, she doesn't really know how to how to count all of them and divide by 2. So what you can do is, in this case, you do not really know what is the exact middle of the string. So if she know how to count, so what does she can do? She will count the total number of alphabets. So for example, 1 2 3 4 5 6 7 8. She knows the total number of alphabets as are 8, and she can do 8 by 2, so that will be 4. That means after the 4th alphabet, again the repetition will start. But in this case, in this number system, she doesn't really know where the half of this will start, right? So what will she do is, she take one stone here, then she take another stone here, then again one stone here, then again another stone here, and so on, right? She'll assume that there's some way I will be able to identify what is the exact middle. Now, if she doesn't know how to find the middle point, so she'll assume that there should be some kind of property. If this property follows, so maybe the middle point is starting. I mean to say, if you see, whenever we have a string, for example, if you have w is equal to aba, and then if you have wr, which is also be aba. So if you do wr, in that case we get aba and again aba. So in this aba, the middle point, this double a's are always repeating. So there will be two a's in the middle. So the middle symbols are always the same. So even if you take any string whatsoever, even if you take the string which is b a a b, correct? So whenever you take a reverse of it, again you can find out in middle point these two alphabets are actually repeating. So what does she do is, she'll say that given a string which is in this format, I do not know what is the middle point, but I will assume whenever I get two symbols which are repeating themselves, maybe the middle point has arrived. So maybe the middle point has arrived, and maybe it is not, right? So maybe the middle point has arrived and maybe it is not, right? So she will start assuming every time whenever these two symbols are coming together, she will start assuming every time that yes, might be the middle point has arrived, so I should do something, I should start removing the symbols from the stack. This is what she will do. And in this case, she is in a state of non-determinism. So she's not able to really determine what is exactly the middle point. And in that case, she will be creating a non-deterministic pushdown automata, because that is a state of non-determinism. Okay. So how can she do that? How can Pratibha make sure that middle point is always there? So this is the initial state Q0. In the beginning you could get a symbol A or you get a symbol B. So if you get a symbol A and the stack is currently empty, you are going to insert that symbol onto the stack and you go to the state Q1. Or if in the beginning the symbol is B, the stack is currently empty, so she is going to insert that symbol B. So in beginning, whatever symbol she will get, she is going to insert that symbol onto the stack. And then every time a new symbol is coming, she will start inserting it. If a symbol B is coming, top of the stack is containing A, she will insert it. If symbol A is coming, top of the stack is containing B, she will insert it. But her problem starts when there are two symbols which are repeating themselves. For example, if we have a string which is A, B, B, A. So if this is the only string, then whenever you have a middle point, then maybe you can say that middle point has started. But if you have a string like A, double B, A, double B, A. So here also there are repeated values, here also there are repeated values, and here also there are repeated values. So what does she has to do? She has to assume that every time whenever the symbols are going to repeat themselves, that means the symbol which is on top of the stack and the symbol which is in the string, that the symbol that she is reading, so she is going to assume that because these two symbols are matching, maybe we got a middle point and maybe we have not got a middle point. She is going to take each of these two cases. तो वो जो है वो दोनों cases को यहाँ पर लेगी. Now what will she do is, if the symbols are matching, in one transition she is going to find out yes, the middle point has reached, and in second transition she is going to say that no, the middle point has not reached. So when she says that middle point has not reached, she is going to insert that symbol onto the stack. So if the symbols are matching, she is going to insert here, and she is going to remove the symbol from here. She is going to insert here, and she is going to remove the symbol from here. So on same string, she is going to do two different operations. And then she can go to the state Q2, and here every time, because she assumes that middle point has arrived, so she is going to remove all the symbol from the stack. So here every A will be matching with A, and every B will be matching with B, because it is the middle point. And as soon as the stack becomes empty, she is going to leave the stack empty, and she is going to accept it to the state Q3. Now in this case, this is your non-deterministic finite automata, or you can say NDFA. So non-deterministic pushdown automata, not finite automata. This is non-deterministic pushdown automata. So in this non-deterministic pushdown automata, so again, because for the same symbol she is taking two different transitions, that is why it is a NPDA. Okay. Let me take an example. So let us suppose we have W is AB, then WR will become BA. Therefore your string WWR, it will become ABBA. And we are giving this string ABBA to this pushdown automata. String that we are giving is ABBA. And this is your stack. This is your initial stack, which is having the symbol Z0. Now what will happen is, we are going to read the first symbol, and currently the stack is having Z0. So we are going to say, if the first symbol is A, stack is having Z0, just insert that symbol. So I'm going to insert A Z0 onto the stack. Then I'm going to read the second symbol. Now the second symbol is B, right? And B is and stack is containing A. So because the second symbol is B and stack is containing A, she is going to insert it. So this B will be inserted onto the stack. Now the third symbol here is B. This is where the problem arises, because the third symbol is B, and here we have the top of stack is also containing B. So we have top of the stack is also matching with the symbol. So in that case, again we have two different transitions here. In one transition it is going to assume that middle point has not reached. In the second transition it is going to assume that middle point has reached. So now this will create two different copies of itself. This pushdown automata will create two different copies of itself. In one copy it will say no middle point, that middle point has not reached. In the second copy it says that middle point has reached. Okay. So in the point where it will say no middle point has reached, in that case she will do this transition and she will insert this B onto the stack. So this second B will also be there onto the stack. And in the second transition where she assumed that middle point has reached, she is going to remove this B from the stack. This B will be removed from the stack. Okay. So these are two different cases, right? Now the next symbol after this is A. Next symbol is A. So the transition which assumed that middle point has not reached, it will say that top of the stack is containing B and the symbol is A. So because it is B comma A, it is going to be BA. That means I'm going to insert this A. This is B. This is top of the stack and this is symbol A. So I'm going to insert this AB onto the stack. And the transition which assumed that middle point has reached, by looking at this A, it will remove this A from the stack. Now the transition which assumed that middle point has reached, that is empty, the stack is empty, and the transition which assumed that middle point has reached, here the stack is having some value. So after reading this entire string, you will get epsilon, correct? So here you can see, do you have a transition for epsilon comma A, because top of the stack is containing A and here the symbol is epsilon. So we can see there's no transition called epsilon comma A. We do not have a transition like this in here. Anywhere there's no transition. So this will go to dead configuration. This will go to dead configuration. You cannot really, this will not be successful. But here the thing which assumed that the middle point is there, it correctly assumed the middle point. So it will happen in this case. In this case, we have a transition which is epsilon comma Z0, and this will go to a final state. This will go to a final state and it will say yes, because final state has reached, therefore this is the string which is present in the language. Then this string is now present. Okay. So you can see every time where we are having these kind of cases, we are making two different transitions. That is why it is non-deterministic. इतना समझ आया? Is it clear to all of you? Is there anyone जिसके साथ ये clear नहीं है? I hope this much is clear to all of you. Any doubts? No doubts? No doubts, then you guys are very smart. Super smart people. Good. If there is no doubts, it is good. Now I can take more examples to explain the same, but I don't think so it is required to take more examples. So let me just go on to the second problem here. Basically there are a lot of problems which are similar to second problem. Okay, so in the second problem they are saying either A should be equal to C or B should be equal to D. See, if you have a problem like this, A raised to power n, B raised to power m, C raised to power n, D raised to power n, such that n comma m is greater than or equal to 1. Now for this problem you cannot make a push down automata. Whether it is deterministic or not deterministic, you cannot really make a PDA for this. But if you have a problem like A raised to power n, B raised to power m, C raised to power m, D raised to power n, such that n comma m is greater than or equal to 1. Now for this problem you will be able to create a PDA. Okay, so why for this problem PDA you cannot make a PDA? Why this PDA is not possible is very simple, is that whenever you get a A, just insert A onto the stack. Whenever you get a B, you will insert B onto the stack. But if you want to compare with C, you are going to compare C with A. In that case, you have to remove all of these B's out of the stack, and then you have to compare C with A. But the problem is, after removing all these A's, how will you compare that D is equal to B? There is no method, there is no way to compare D with B. Okay, so you can clearly say that for this problem you cannot really make a PDA. So आप इसके लिए PDA नहीं बना सकते. But for the second problem, the PDA is possible. How can the PDA is possible? You are going to insert all this A, then you are going to insert B, and then you can compare C with B, and then you can compare D with A. So for this second case, the comparison is possible, but for the first case, comparison is not possible. Now if you look at this problem here, in this problem they are saying either A should be equal to C or B should be equal to D. Right? So we are not saying that both of these conditions should hold together. What they are saying is either A should be equal to C or B should be equal to D. There are two different cases. So what you can do in this case is you can make a non-deterministic PDA. Okay, so you can take a state here, you can take a state Q0, and then you can make two transitions here, the first transition and the second transition. In the first transition you can assume that A should be equal to C. In the second transition you can assume that B should be equal to D. And whenever you give a string, if any one of these two cases we reach a final state, then we say the string is accepted, otherwise the string is not accepted. Clear? Right? So if you look at it here, how can you do it? We have A, symbol A. Okay, in the first transition I'm going to say that A, that is n, is equal to L. In the second transition I'm going to assume that m is equal to k. These are two different transitions. Okay, so in the first transition n is equal to L. In the second transition m is equal to k. This is what I'm going to do. Then how will you do it? कैसे करेंगे आप इसको? Just try to make it. It's very easy, very easy. So this is the initial state, which is Q0. So in the beginning, if you get a symbol A, the stack will be empty. I'm going to insert the symbol A onto the stack. I go to the state Q1. Now whatever number of A's are there, so the stack will be containing A. You're going to insert all of them. Now as soon as there's a B, you will say that I'm not going to do anything, leave A as it is. You can, because you're not counting B, right? So you can have any number of B's. You are going to leave all the A as it is. As soon as you get a C, you will compare the C with A's, and you are going to remove it. You go to the state Q3, and now any number of C you will get, you compare C with A, and you are going to remove all of them. Then as soon as you get a D, stack will be having Z0, leave it Z0, and you are going to accept it, right? So here you can have any number of D, stack is having Z0, leave it to Z0, and you are going to accept it, right? So here this is not an acceptance by empty stack. Here we are not accepting the string with it. So so basically here stack is still empty. Again, it is acceptance by empty stack, because when you are accepting the stack is empty, you are not inserting D here. Okay, it is acceptance by empty stack. But if you look at the second case says when B should be equal to D, and we are not counting A and C. So in that case, in the beginning, if you get a A, just do not insert A onto the stack, go to the state Q5. You can now get n number of A's, do not insert any of the A onto the stack. As soon as you get a B, you will insert this B onto the stack. You can get n number of B's, so insert all these B's onto the stack. As soon as you get a C, do not do anything, just leave all the B as it is. You can get n number of C, leave all the B as it is. As soon as you get a D, now compare B with D and remove the B's. You can get n number of D, compare B with D and leave it as it is. As soon as you get epsilon, string is empty, stack is empty, and then you are going to accept it in the state Q9. So basically what I have done is I have created one initial state and I have combined two different PDAs here. So this is the first PDA which says A should be equal to C. The second PDA says B should be equal to D. And now if we give any string whatsoever, let us suppose if we give a string A, B, 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 C, D, 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 right? So in this string A and C are equal. So what will happen is whenever you give this string, this PDA will make two different copies of itself, because here we have two different transitions for the same symbol. And then if any one of these copies can lead to a final state, then we can say the string is accepted, otherwise the string is not accepted. Is it clear to all of you? क्या आप सभी के साथ ये clear है? Any doubts till now? Not clear. Please ask Pratibha, what is your doubt? Sorry. So Pratibha, basically here we are making two different transitions for the same symbol, right? So because we are making two different transitions, so if you give a string, let us suppose if you give a string, what will happen? By reading a symbol A, we will go to two different states. So we will go to Q1 as well as Q2, just like in a finite automata. If we have a non-deterministic finite automata, in a non-deterministic finite automata, if by giving a string you can reach to a final state, right? See, non-deterministic finite automata, just by giving a same string, it will make different copies of itself. And if any one of these copies leads to a final state, we say that string is accepted. In this case also, when you give this string to this pushdown automata, here this pushdown automata make two different copies of itself, right? So in both the cases, both these things will work parallelly. And if any one of the copies can lead to a final state, then we can say the string is accepted, otherwise the string is not accepted. So here if you give the string A, then you will reach to the state Q1 as well as you will reach to the state Q5. So basically it's just like a binary tree. So it is making a binary tree, and if the leaf node becomes of that, if the leaf node of that binary tree become a final state, then we say it is accepted, just like this. Okay, so इतना clear है? So basically this concept is देखो concept जो है, concept is similar, just like finite automata, the concept is similar. Finite automata में non-deterministic pushdown automata, sorry, in finite automata non-deterministic finite automata का जो concept है, so how can you accept a string in NFA? The same thing is applicable on NPDA. In case of NFA, if for a given string you can reach a final state, the string is accepted. In the same way, in case of NPDA, if for a given string you can reach, any of the copies can reach to a final state, then we can say the string is accepted. Otherwise, the string is not accepted. Okay, let me do one thing. You will understand it with more examples. Okay, let me take some more examples here. So you have to tell whether you can make a finite automata for them or PDA or them or not. Okay, let me just write some of the examples. You will find it interesting. Okay, so this is something that I'm doing specifically. Yes, Pratibha, I'm taking this example, that you are mentioning right now in the chat. I'm taking the same example here. Just give me a second. Let me write it down on your boards also. Now the example that you have taken, you cannot make a PDF for this. Either this is deterministic, non-deterministic, आप उसके नहीं बना सकते. Why? Because you can compare A with B. So आप पहले A को stack में डलवाएंगे, फिर B से A को compare कराएंगे, तो उससे क्या होगा कि जितने भी A हैं वो सभी stack से बाहर निकल जाएंगे. Then how will you compare C with A? आप C को A से कैसे कंपेयर कराएंगे, राइट? सो दैट इज़ वाई जो एग्जाम्पल आपने लिया है, फॉर दैट एग्जाम्पल यू कैन नॉट रियली मेक अ okay. So I'm taking some of the languages here. So these are languages, and you have to tell whether you can make a finite automata for them. So it includes both NPD or DPD, right? Then you have to tell whether you can make a deterministic pushdown automata for them, or whether you can make a pushdown automata. So this pushdown automata contains both NPDA as well as DPDA. So if for a language you can make a finite automata, that means the language is regular language. If for a language you can make a deterministic pushdown automata, then we can say the language is deterministic context free language. If for a language you can make a pushdown automata, then we can say the language is context free language. Okay, so it is a difference between all three of them, and you have to tell कि आप क्या क्या कर सकते हैं इसमें से, क्या क्या नहीं कर सकते. ठीक है? So let's do it, I guess. Let me check one more marker. I have one more marker here. Just give me a second. Let me fill some ink on this also. Okay, so let us take the first language here. So the first language is a raised to power n such that n is greater than equal to 1. Second language is a raised to power n b raised to power n such that n is greater than equal to 1. The third language is a raised to power n b raised to power n such that n is greater than equal to 0. The fourth language is a raised to power n, b raised to power n, c raised to power n such that n is greater than equal to 1. Fifth language is a raised to power n, b raised to power m, c raised to power n such that n is greater than equal to 1. Sixth is a raised to power n, b raised to power n plus m, c raised to power n such that n is greater than equal to 1 and comma m is greater than equal to 1. Seventh language is a raised to power m plus n, b raised to power n, c raised to power m such that n comma m is greater than equal to 1. Eighth language is a raised to power n, b raised to power I, c raised to power m, d raised to power n such that n comma I comma m greater than equal to 1. Ninth language is a raised to power n, b raised to power m, c raised to power n, d raised to power m such that n comma m is greater than equal to 1. 10th language is a raised to power n, b raised to power m, c raised to power m, d raised to power n such that m comma n is greater than equal to 1. 11th language is a raised to power n, m, b raised to power n, c raised to power n, d raised to power m such that n comma m is greater than equal to 1. So basically this 10th and 11th both are same. And the 12th language that I can take here is a raised to power n, b raised to power 2n such that n is greater than equal to 1. I hope this much is visible. Yes. So first let's take this example. So for the first language here, can you make a finite automata? So jaldi se please write your answers in the chat window. So just write yes. So what you can do, you can write answer in this way: yes, no, no. Right. So y is for this one, n is for this one, and n is for this one. So this way you can write your answers. Okay. So you can write your answers in the chat window. Start writing. I want all of you to participate here. When I ask questions, I want all of you to participate because your participation is very, very important. Okay. So for the first case, for the first language, you can make a finite automata. Now for any language, if you can make a finite automata, definitely you can also make a PDA, right? So for this, PDA and NPDA is also possible. So because let's see, there are 12 people are watching, I want all of you to answer, not just one person. I want all of you to participate in this class and answer in the chat window. So jaldi se sabhi ke answer chahiye mujhe. Please write your answers. Just write like one why. 2, you can say why, no, something like this. So this way you can answer write your answers in the chat window. Okay. So if you see the second case here, for second case you cannot make a finite automata. You can make a deterministic pushdown automata, and as well as you can also make a PD. अगर आप किसी language के लिए, for a language your deterministic PDA is possible, obviously PDA is also possible. If you see the third language here, you cannot make a finite automata for this. Why? Because you have to compare A with B. Here also you have to compare number of A with the number of B. So in case of PDA, you can store them in a stack and then you can compare, but in a finite automata we do not really have infinite memory. Given an instance you can make, but for the entire language we will not be able to make one, right? So this is yes as well as yes. Now for this fourth language here, we will not be able to make a finite automata, we will not be able to make a deterministic PDA, as well as we will not be able to make PDA. तो यहाँ पर PDA deterministic PDA हम लोग नहीं बना सकते. Okay. So for the fifth case here, for this language, which is a raised to power n, b raised to power m, c raised to power n. So basically we have to compare a with c, we do not have to do anything with b. So in this case you cannot make a finite automata, but yes, you can make a deterministic pushdown automata, and you can also make a pushdown automata. If you see the next language here, a raised to power n, b raised to power n plus m. So what you can do is insert all the a onto the stack, then you get b's, so remove all the a from the b's, and then you will get extra b, insert all these extra b onto the stack, and then you can compare b with c. So I think I should write it this way, c raised to power m, right? So this is actually a raised to power n, b raised to power n plus m, c raised to power m. So then you can make a dpda as well as npda for this, but you will not be able to make a finite automata. In the next case here, a raised to power m plus n, b raised to power n, c raised to power m. So insert all these a onto the stack. Whenever you get a b, remove a. Whenever you get a c, remove a. If the stack is empty, then it is accepted. So again, you can make a dpda for this. Next, for this language, here what you have to do is you have to compare a with d, but you are not doing with any number of b and c. So again, इसके लिए भी you can make a dpda and npda, but you cannot make a finite automata. Now for this next language here, we are comparing a with c and b with d. But the problem is, once you are going to insert this a inside the stack, after this a you will get b, you have to insert this b inside the stack, then you have to compare c with a. To compare c with a, you have to pop b out, then you can compare c with a. But the problem is, then you will not be having anything to compare with d. Stack will be empty and you cannot compare with d. So here you cannot make a dpda as well as a npda for this. Okay. Now for the 10th one here, what you can do is insert all this a onto the stack, insert all the b onto the stack, then compare c with b, and then compare d with a. So here you can make a dpda as well as you can also make a npda, but you cannot make a finite automata for this. Okay. Now next language here we are comparing a with d. So because we are comparing number of a with the number of d, and basically this 10th and 11th both are same, so these are same languages here, so that is why same answer will be there. But for the question number 12, you can make a dpda as well as you can also make an npda, but you cannot make a finite automata. I think this much examples we have done, right? So let me take more examples, but again, is there any doubt till now? इतने examples हम already ले चुके हैं. I will take more examples now. आप इसको note down कर लीजिए. After noting it down, write done in the chat window so that I can write more examples. Sure, so take your time, note it down. After noting it down, write done in the chat window. Sorry. Could I have hoped that all of you have written? So let me rub it up. Now let me write more examples here. So the language is a raised to power n, b raised to power 2n such that n is greater than equal to 1. This is something that we have already seen till now. इसको हम already देख चुके हैं. Next language is a raised to power n, b raised to power 2 raised to power n such that n is greater than equal to 1. Then we have a raised to power n, b raised to power n square such that n is greater than equal to 1. Then we have a raised to power n, b raised to power 2n, c raised to power 3n such that n is greater than equal to 1. And then we have w, c, wr such that w belongs to a comma b plus. Then we can have w, x, wr such that x belongs to x comma w belongs to a comma b plus. Then we have w, wr such that w belongs to a comma b star. Then we have something like a raised to power n, b raised to power m, c raised to power k, d raised to power l such that n is equal to k or m is equal to l. So ये हम लोग already कर चुके हैं. We have already seen this. So I'm writing it again. Sorry. So we can say a raised to power I, b raised to power j such that I is greater than j. Okay. Then we have a raised to power I, b raised to power j, c raised to power k such that I is greater than j or j is greater than k. Maybe a raised to power I, b raised to power j, c raised to power k, d raised to power l such that I is greater than k or j is greater than l. So write down these examples. So this is, I guess last time I got till 11, right? So this is 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20, 21 and 22. Don't worry, if it is not visible, not a problem. I'll repeat it. So then don't worry about it, okay? Now for the first language here, that is 12. We have already seen this. We cannot make a FA for this, but we can make a DPDA as well as we can make a NPDA. Now what is the problem with the second one here? It says b raised to power 2 raised to power n. That means number of b are exponential as compared to the number of a. See, the problem here is in the 12th one, 12th ke case mein, here this is basically a AP. So number of b's are coming in a arithmetic progression, right? So we can have number of here be 2, 4, 6, 8, 10 and so on. So this is creating an arithmetic progression, but here it is not creating an arithmetic progression, but it is growing exponentially. So maybe so here you cannot have an AP, right? So here you cannot make a finite automata, you cannot make a DPDA as well as you cannot make a NPDA for this. आप इसके लिए DPDA, NPDA कुछ भी नहीं बना सकते because you are not even having a AP, arithmetic progressions here. If you look at the 14th case, so in case of 14th, b raised to power n square. So n square is again, it is not growing linearly, it is not growing like an arithmetic progression. So here also you cannot make a DPDA, you cannot make an NPDA, obviously you cannot make a finite automata. Now in the 15th case, okay, so in the 15th case here, when I say 15th one, so it is a raised to power n, b raised to power 2n, c raised to power 3n. Now in this 15th case, what you can do is you can compare a with b. But the problem is, how will you compare C with anyone? You cannot compare C with anyone, right? So again, for this, you cannot make a FA, you cannot make a DPDA, you cannot make a NPDA. Okay. Now for the 16th case, we have already seen this. 16th case ke liye you cannot make a FA, but you can make a DPDA, as well as you can also make a NPDA. Now for the 17th case here, so in the 17th case, it is WX WR, and we have already seen this, because if X is also A comma B plus and W is also A comma B plus, in this case we can say yes, you can make a finite automata, you can make a DPDA, as well as you can also make a NPDA for this. Now for the 18th case is WWR, right? So you cannot make a FA, but you can make you cannot make a DPDA, but yes, you can make a NPDA. तो हम यहाँ पर DPDA और DPDA नहीं बना सकते, but you can make a NPDA for this. Now for the 19th case, it is either A should be equal to C or B should be equal to D. So again, you can make a NPDA for this, but you cannot make a DPDA for this. And then we have A raised to power I, B raised to power J, such that I is greater than J. So that means number of A should be greater than the number of B's. So here PDA is possible, NPDA is also possible, but FA is not possible. For 21st case, it is either A should be greater than B or B should be greater than C. So here you can make a NPDA, but you cannot make a DPDA, as well as you cannot make a finite automata. Okay. So but leave this 22nd because it is not visible on the in the video. So leave the 22nd one. So you can note it down till 21st. So note it down. If you have doubt, please ask. Otherwise, I will take more examples. अगर आपको कोई भी डाउट है, you can ask. Note it down. So सभी जल्दी से just write down in the chat window if you have noted it down, so that I can rub it. Good. So 15th is not clear. See, what is the problem with the 15th one? Because here in 15th you have A raised to power n, B raised to power 2n, C raised to power 3n. But the problem here is you can insert A onto the stack. So you can do any strategy. You can insert 2A onto the stack or 1A onto the stack. That is your choice. And then to compare the number of B with A, you can remove all this A. So after you have compared with B, so stack will become empty. After the stack is empty, how will you compare with C? अब स्टैक जो है अगर एम्प्टी हो जाएगा तो आप कैसे कंपेयर करेंगे कितने सी थे, राइट? सो सम स्टूडेंट माइट से कि सर डू वन थिंग सर, लेट अस डू वन थिंग, व्हेनेवर यू हैव अ ए इंसर्ट 5a, करेक्ट? सो सम स्टूडेंट माइट से सर व्हेनेवर यू हैव अ ए इंसर्ट 5a, ओके, एंड व्हेनेवर यू हैव अ बी रिमूव 2a, whenever you have a C again remove a, right? So some student might say this, but the problem is when you insert 5a, it does not guarantee that number of B is double as compared to the number of A, correct? So what you can do is, let us suppose if the string is this way, A, B, 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 and C, 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 okay? So here what you can do is insert 10A, and then you will say, okay, sir, after inserting 10A, remove 4B, and you can say remove 4C. But the problem again here is, you do not really know whether the string will be in this format, or sometimes you might get the string in this format. So again, both of these strings will get accepted. If you insert 5A and then you remove with B and remove with C, again you will not be able to identify which of the two cases is there. Okay, so for this you cannot really make a Pushdown automata, because you have to compare A with B, but then you have to compare A with C also. So number of B should be double of A and number of C should be triple of A. So if you compare number of C with A, right, so then all the A will be removed from the stack, then how will you compare the number of C? So there is nothing left to compare with C with A. Okay. Pratibha, you are saying if push A and B and then popping from for C, because n is common, so that is not a correct way. Why? Because in that case, if you have like something like this, 4A, 2 C's, and you have 2 B's and you have 6 C's. So again this string, so you are saying push all the A, push all the B and remove from C, so this string will get accepted, but again this string does not exist in this language. The string है, इस language के exist नहीं करती. So the strategy that you are following a strategy that push all the A, push all the B and then compare with C. So in that case, this string will also get accepted, but this string is not present in the language. Okay. So you can take it like a, yes, C is always A plus B, but see, the language is A raised power n, B raised power 2n, C raised power 3n. You have to make sure that number of B should be double of A. So you are just not saying that, you are just not comparing C, but you are saying is, you are checking about this language. You are saying A raised power n, B raised power m, C raised power n plus n. So this is a different language. So the strategy that you are giving me is for this language, and the language I have given is A raised power n, B raised power 2n, C raised power 3n. So, right? So this is a different language and this is a different language. Both of these two languages are having different strings. So the strategy that you are giving me is for this language, it is not for this language. Is it clear? So think about it, try and make it, right? Just take some time and think about how can you make it. If you can make it, definitely you will get the Turing award. Do you know what is Turing award? Pratibha, do you know what is a Turing award? How many of you know what is a Turing award? No. Okay. Have you ever heard that a computer scientist ever got a Nobel Prize? Computer science is not in the category of Nobel, right? So in Nobel Prize category you get physics, you get science like chemistry, you get biology, you get medicine, right? But you do not have a computer science discipline in Nobel Prize, because they do not really consider that computer science people are doing something good for the humanity. So that's just a joke, by the way. So anyways, so basically what happens is, there's a scientist called as Alan Turing. So Alan Turing, in the Second World War, he was acting as a god. So you can just see his movie, right? So let me give you the name of the movie, Alan Turing movie. So you can take it as a homework. It's a very interesting and easy homework. Interesting, or I should say that it is a kind of homework that you will enjoy. So today, after the class, go and watch the movie The Imitation Game. The Imitation Game. The Imitation Game. So this is this movie on the scientist, which is Alan Turing, and Alan Turing was considered as a god of computer science. So basically, the highest award that you can get in the field of computer science is the Turing Award. And in our subject, we are discussing about the Turing machine, and this Turing machine is designed and named under the named on the scientist, which is Alan Turing. So watch this movie after the class today. You will really enjoy it, and then we can have a discussion regarding this. Okay? So the highest award in computer science is Turing Award. Now look at these example languages. We have A raised to power n raised to power n such that n is less than or equal to 10 raised to power 10 raised to power 10. A raised to power n, B raised to power n, C raised to power n such that n is less than or equal to 10 raised to power 10 raised to power 10. A raised to power n, B raised to power 2n, C raised to power 3n, D raised to power 4n such that n is less than or equal to 2 raised to power 2 raised to power 2 raised to power 2. Okay. Then you have an, bn such that n is greater than or equal to 5. But if you have an, bn such that n is less than or equal to 10 raised to power 10 raised to power 10. Okay. Then we have w, wr such that length of w is less than or equal to 10 raised to power 10. you have WCWR such that length of W is less than equal to 10 raised to power 10. Okay, so look at these languages and tell me if you can make a finite automata for them. So this case is interesting. So for these languages, for the first language you can make a finite automata, you can make a DPDA as well as you can make a NPDA. How can you make it? How can you make a finite automata for this? You will see that, sir, okay, let me give you one more example. If I write, we have a language which is a raised to power n square such that n is greater than equal to 1. So for this a raised to power n square, you cannot make a finite automata, you cannot make a DPDA as well as you cannot make a NPDA. Because in case of a raised to power n square, this n square is not creating any arithmetic progression. ये AP create नहीं कर रहा. But in the second case here, there is a raised to power n raised to power n. So this is again not creating an AP, but the interesting fact is the length is limited. I mean to say this language is a finite language, it is not an infinite language. The number of strings which will be present in this language is not infinite, it is finite. So because the language itself is finite, therefore finite automata is possible. See, whenever the language is infinite, then it might be possible that finite automata is possible, it might be possible that finite automata is not possible. But if the language itself is finite, that is the number of strings in the language is finite, then finite automata is always possible. So for this language, finite automata is possible. For this language, finite automata is possible, DPD is possible, NPD is possible. Even though this number is very, very huge, but again, the language is finite. So finite automata is possible, DPD is possible, as NPD is also possible. So again, for this language, FA, DPDA, NPDA, all of them are possible. Now for this language here, it is not a finite language, it is an infinite language. Here FA is not possible, DPDA is possible, NPDA is also possible. Now for this language, it is a finite language because n is less than or equal to 10 raised to power 10 raised to power 7. Even though it is very, very huge, again in this case, FA is possible, DPD is possible, NPD is possible. Now this language here, FA is possible, DPD is possible, and NPDA is also possible. Why? Because this language is again finite. It is not containing infinite number of strings. Now for this language, WCWR, where W is less than or equal to 10, the length of W. So again, FA is possible, DPD is possible, NPD is possible. So you can clearly see whenever you have a language where the length of the string is limited, I mean the number of strings in the language is finite, right? So here you can see the number of strings in the language is finite. We cannot have infinite number of strings. So if the number of string itself is finite, then finite automata is always possible. I hope this one answered a lot of query for you, Pratibha and Mary. Most of you, these things I hope all of them answered a lot of questions for you. Okay. So you must have learned something new by this. तो कुछ नई चीजें आपने पढ़ी होगी from this example. Okay. Now again, we will take more examples when we will study your Turing machine. After studying Turing machine, you will I'll introduce you to the more languages. There are more new kind of languages. For some languages, a lot of languages where you cannot make a PDA or NPDA. But again, for those languages, you can make a Turing machine. So now here, you got some concept related to the pushdown automata. You know what is PDA and what is NPDA. You understood a lot of things here today. Now this is the point where you can start solving previous year questions. Because before this point, I can say that to solve the questions, you need a lot of background knowledge. Now you got some background knowledge, and I hope after studying till this point, after studying till this pushdown automata, you will be able to solve 10 to 20% of the questions which was asked in the question papers, in the previous year questions. You will be able to answer 20% questions till this time. Now after 2 or 3 more classes, you will be able to answer 70 to 80% questions. Okay. So this is the fact, right? So first you have to understand how to even make a finite automata, right? And slowly when concept grow, you do not have to spend a lot of time. Like for example, within today we introduce PDA and we introduce what is NPDA, right? And within like 2 or 3 hours of class, you will be able to understand what is a PDA, what is a NPDA. But just to understand the finite automata, you needed you needed around 5 to 6 classes. Okay. So what I will do is for the next class, I will update the time in the Telegram group. Okay, and right now what you can do is take some break and go through the previous year questions and just practice some of them, try to solve some of them. You will be able to solve around 20 to 30% questions till this time. After I finish my next class, which is your grammars, you will be able to solve next 30% of the questions. So in next 1 or 2 classes, right, even if I take 2 more classes, so will be, with the help of those 2 more classes, you will be able to solve 50% of your TOC questions. Okay, so take a break and then I'll update you after the break. Okay, yes, I've shared PYQ for TOC with all of you. तो मैं PYQ की जो PDF वो पहले ही शेयर कर चुका हूँ, previous year questions, so you can go through that. Okay, and just do one thing, try to solve previous year gate questions also, not just UGC-NET, because in UGC-NET they are also asking previous year gate questions nowadays. So you can try in solving previous year gate questions also. Sure, I will forward you again. So till that time you can solve gate questions also. I'll send you this PDF file again on the Telegram group. Just send me a message, Pratibha. Okay, so I'm finishing this class right now, and I'll update you the timing for the next class in some time.